So for this part, we're going to discuss partition and equivalence classes. First, let's define what we mean by a partition. A partition, or let's say we have a non-empty set X. A partition script letter T of X. So we, again, to remind everyone, we are using a script letter to denote a family of set. So a partition is a family of set coming from X. So we mean a set of non-empty subsets of X such that it follows or satisfies the following. Pag meron kang dalawang element ng partition natin, then the intersection of the partition is empty. Meaning, these two partitions are disjoint. Yun yung ibig sabihin nun. So whenever you get two elements of the partition, you're always, these two elements are always disjoint. So pag sinabi mo disjoint, walang common element. Meaning the intersection will be empty. Okay, so that's what we mean by AB from the partition to be disjoint. So ang tawag natin dito, the partition itself, we call it a mutually disjoint partition. So T is mutually disjoint. Okay? So pag sinabi mo ang isang partition ay mutually disjoint, ibig sabihin, or pag sinabi mo ang isang collection of set ay mutually disjoint, then pag kumuha ka ng dalawang element ng family na yon or ng collection na yon at kinuha mo intersection for any two, for any arbitrary elements of this collection, then their intersection is empty. Okay? So, walang set dun sa partition mo na may intersection. So, ibig sabihin, kung titignan mo, ganyan, iwahiwalay siya. Walang common, walang overlapping ng elements. And then the second criteria for it to be considered a partition of X, dapat when you get the union of these elements or these subsets, okay, pag elements, ibig sabihin element siya ng T ha, kasi ang T, collection siya ng sets. So pag yung mga element ng partition, kinuha mo yung union, then you get the intercept. So the collection contains all of X. Okay? So, hiwa-hiwalay siya, hindi siya nag-overlap, pero pag pinagsama-sama mo sila, buong X yung nakukuha mo. Meaning, ang bawat isang element ng X, so for any element of the set X, dapat iyon ay nasa isang part ng partition. So, it should be contained in some A sub gamma in the partition. Kung ano mang set yon. Okay? So, kada isang element ng X ay nasa isang set dun sa collection natin, dun sa partition natin. At kada dalawang partition, distinct partition, or rather distinct element of the partition, walang common na element ng X doon sa dalawang subset na yan. Okay? So that's what we mean by a partition. Ibig lang sabihin, a partition is really nothing but a cutting up. Parang hiniwa-hiwalay mo lang yung X into a non-empty disjoint subsets. Okay? So, yun yung ibig sabihin ng partition. Pag hiwa-hiwalayin mo lang siya into non-empty, ika-cut up mo siya into non-empty subsets. So, halimbawa, meron tayong X to draw it. Meron kang set A, B, C, D, E, F, and G as drawn. So, ang ibig sabihin nito, yung A tsaka yung B, wala siyang common element. Although, magkatabi sila sa partition, no common element there. Same with the rest of the elements. So yung A, B up to G, those are the elements of the partition P. Okay? So again, pag kinuha mo yung kada dalawang distinct subset or element ng partition, walang disjoint sila. So walang common element. And then pag pinagsama-sama mo lahat ng nasa partition na yon, dapat makukuha mo yung buong X. So that's what we mean by a partition. Let's have some mathematical example. Let E denote the set of even integers, and O denote the set of odd integers. So, to write that, E is simply set of even integers, di ba? So, that's the element 2n for all n in the set of even integers. So, ano mga laman nun? 2, 4, 6, 8, 0, negative 2, negative 2, negative 4, and so on. Ano naman yung mga O? O is the odd numbers. So, 2n plus 1 for all n element of Z. So, ano laman yan? Hindi, 1, 3, 5, 7, and so on. Tama? And then, negative 1, negative 3, negative 5, and so on. Well, we already know, this is already a fact that E intersection O is empty. Walang common element ang O tsaka ang E. Right? Ayusin natin yung ano natin. So this is E. And this is capital O. Ayan. Okay? And, similarly, likewise, ang union ng dalawa, we know that lahat ng even at lahat ng odd comprise the set of integers. So, E and U is a partition. Okay? That's a partition of C. A partition, you should remember, is not unique. There are a lot of ways on how you can partition C. There are infinitely a lot of ways. For example, kunin mo yung isang set to be the singleton. Di ba? Di ba? Kunin mo yung n sub or z na lang. C sub n to be just the single element n. Yun lang yung laman niya. Just the single element n. Wag nang ganyan. Ganito na lang. Ayan. So, it just contain the single element n. O, di pag pinagsama-sama mo lahat ng n, alam natin na ang laman ni 1, di ba? Tsaka intersection laman nito, empty. Actually, for any I and J, di ba? Basta yung I not equal to J, ha? Basta yung I not equal to J. So, any two element of such partition, empty. And if we combine all of them, if we get the union of all I for all I in C, makukuha mo yung buong integer. So, partition siya. Di ba? Yung set na I for all I in C, that's a partition. Okay, ang laman niya, mga singleton, mga set na ang laman, set na containing 1, set containing 2, set containing 3, and so on and so forth. So, lahat yun. So, again, a partition is not unique. There are a lot of ways on how you can partition C. Okay. Of course, this is not an interesting partition, ito. Kasi syempre, isa lang yung laman ng element. Okay. Let's have another way to partition C. So, let M be an integer. For any integer from 0 to m minus 1, let's consider bracket k sub m. Yan. Ano laman ng bracket k sub m? Ang laman niya, lahat ng x na integer such that x is congruent to k modulo m. Okay. So medyo interesting na to. Ang laman ni x, ni bracket k, ang laman ni bracket k, lahat ng x na congruent kay k. So meron kang fixed integer m, para magsilbing modulo mo. And then, from 0 to m minus 1, meron kang m distinct subsets. Okay, so let's try as particular value. Sabihin natin m equals 3. So, pag m equals 3, meron tayong 0, 1, tsaka 3 minus 1, 2. So, 0, 1, and 2 for our j. Okay? So, let's say j equals 0. So, ano yung 0 bracket? Sub 3. So, yung 0 bracket sub 3, if we write the definition, that's x, all integer x such that x is congruent to 0 mod 3. Now, ano ibig sabihin na ang x congruent to 0 mod 3? So, if we recall again the definition of the modulo, Ano ibig sabihin nun? Dapat ang x minus 0 ay equal to some integer times 3. Or 3n na lang, 3n. For some n. For some n. So there must exist an n such that x minus 0 can be written as 3 times n. Or in short, x can be written as 3 times n. So mga multiples ni 3. Okay? Ibig sabihin, yung set na 0 bracket sub 3 are all multiples of 3. So we can write this as the set containing all 3x such that, or all 3n rather, 3n. Such that n is an integer. In short, lagay mo lang lahat ng multiples ni 3. So sa negative side, that's negative negative 9, negative 6, negative 3, lahat 'yon. Up to the negative infinity, negative 27, negative 30, and so on. So lahat. 0 sa positive side, 3, 6, 9, and so on and so forth. Okay? So lahat ng multiples ni 3. 0 bracket 3. Ano naman yung 1 bracket sub 3? Well, if we write the definition, that's all x. X is just a dummy variable, ha? All x such that x minus 1 is congruent to 1 modulo 3. Now, what does it mean for an x to be congruent to 1 modulo 3? So, by definition, that's x minus 1 is equal to some 3 times n. For some n. Okay? Or in short, x can be written as 3n plus 1. So, any number daw na pwede mong isulat in the form of 3n plus 1. In the language of number theory, ang ibig sabihin niyan, pag dinivide mo ang x sa 3, ang remainder niya 1. For example, ang 6, pag dinivide mo sa 3, 2 times 3, remainder 0. Ang 7, pag dinivide mo sa 3, 2 times 3 plus 1. Diba? Remainder 1. 2 times 3, remainder 1. So, yun yung 7. So, meaning 7 can be written as 3 times 2 plus 1. So, it is of the form 3n plus 1. Ano pa? Halimbawa, yung 8. 8 is 3 times 2 plus 2. Laging 3 times something. Laging 3 times n plus something. Ngayon, kung yung plus something na yan ay naging 1, edi 3n plus 1 siya. Tama? Sulat ko ang 7 can be written as 3 times 2 plus 1. Ang 8, 3 times 2 plus 2. Ang 9, 3 times 3 plus 0. Ang 10, so kung mapapansin nyo, paulit-ulit lang yan. Plus 1, plus 2, plus 3. Ang 10, 3 times 3 plus 1. Tama? Ang susunod, 3 times 3 plus 2. So meaning, kung gusto mong malaman kung ano yung mga 3 times 3 plus 1, yun yung magsasubstitute ka lang ng number n dun sa 3n plus 1. Okay? So those are the number 3n plus 1 for all n element of C. So kung magsasubstitute tayo ng specific number for, let's say, n is equal to 0, so we have 1. N equals 2, so we have 4. N equals 3, so we have 7. N equals 2 rather. N equals 2, we have 7. N equals 3, we have 10, and so on. Yan. Siyempre, kasama din dyan yung mga negative. Halimbawa, negative 1. So, 3 times negative 1, negative 3 plus 1, negative 2. So, kasama din yung negative 2. 3 times negative 2, negative 6 plus 1, negative 5. Or in short, actually, mag-minus 3 ka lang ng mag-minus 3. Minus 8, minus 11, and so on and so forth. So, all of these numbers, when you divide it by 3, the result is 1. Or in short, there can be written as the number 3n plus 1. Okay? So ano naman yung bracket? So let me write it ng mas compact. So that negative 11, negative 8, negative ano sinunod ko kanina, negative 5, negative 2, 1, 3, 4, and so on. Okay. So, for 2 so we already know the pattern, so that's all x in C, such that x can be written as 2 modulo 3. But when you say 2 modulo 3, that just means that x minus 2 is equal to 3n. Or that means that x can be written as in the form 3n plus 2. Yan. So that's all set 3n plus 2 such that n is an integer. Or if you want to write down the elements, so that. So when n is 0, okay, mag negative natin simulan. When n is negative 2, so 3 times negative 2, negative 6 plus 2. So that's negative 4. When n is negative 1, 3 times negative 1, negative 3 plus 2, that's negative 1. Or actually, plus 3 ka lang ng plus 3. So 2 plus 3, 5 plus 3, 8, and so on and so forth. So these three are the J brackets of 3. J bracket. Okay? So the set 0 bracket 3, 1 bracket 3, and 2 bracket 3 are the numbers that when you divide by 3, you get the remainders either 0 or 1 or 2. There are no other possible remainder, di ba? Yan lang yung possible remainder when you divide by 3. Hindi pwedeng may remainder 4. Sobra pa yun ng 3 eh. So, ang possible remainder lang when you divide by 3, either 0, 1, or 2. So, for any m, that's true. For any m. So, when you get a fixed number m, so all the possible remainders are 0, 1, 2, 3, and so on up to m minus 1. So, you have m distinct remainders. Remainder 0, remainder 1, remainder 2, and so on. Okay. So, as you can see, here in our computations, yung mga element natin na 0 sub 3, 0 sub 1, tama, 1 sub 3, tsaka 2 sub 3, walang common sa kanila. Walang common element, di ba? Yung 9, yung 9, makikita mo lang siya sa 0 bracket 3. Dito lang. Wala siya sa 1 bracket 3, wala siya sa 2 bracket 3. Wala. So, nandun lang siya sa 9. Sa 0 bracket 3. Ganon din yung negative 8. Nandun lang siya sa 1. Yung 5, nandun lang siya sa 2. So, all of these elements are mutually disjoint. Lahat ng element ng partition na to, mutually disjoint. Rather, collection pa lang pala. Hindi ko pa sinasabing partition. Collection. Now, if you get the union of these three, kung mapapansin nyo, ang magiging union, lahat ng integers. Di ba? Kasi ito lahat ng integers eh. Ito lahat ng ang remainder 0, ito lahat ng remainder 1, ito lahat ng remainder 2. And there's no other integer beside these three. Lahat ng integers, either remainder 0 pag dinivide mo sa 3, remainder 1 pag dinivide mo sa 3, or remainder 3 pag dinivide, or remainder 2 rather, pag dinivide mo sa 3. So they are mutually disjoint and they consist of all integers. Therefore, this is a partition. This is a partition of C. Now, ang maganda sa partition na to, kung mapapansin nyo, infinite din yung set din natin. Each set is infinite. Diba? Okay? In general, this collection, the collection, anong collection? Yung 0, bracket M, 1, bracket M, 2, bracket M, and so on, up to M minus 1, bracket M, is a partition of Z. So, for any M, this set is a partition. So, pag 3, ito yung tatlong partition. Pag gumamit ka ng 4, 4 yung elements ng partition. Pag ginamit ka ng M equals 5, 5 yung element ng partition. So, each value M gives you a partition. Okay? And each of these partition are different partitions of Z. Okay? So, I guess at that point, medyo naiintindihan na natin yung ibig sabihin ng partition. Okay, so let's continue. So, let R be an equivalence relation on X. So, given na yung R natin, equivalence relation. So, Here, we define the equivalence class determined by X as the set X over R defined as follow. So, Y is an element of X such that X is related to Y. So, the set of all equivalence classes in X is denoted by capital X over R. Meaning, capital X over R is the set containing all equivalence classes. So, to distinguish the two, yung small x over R, ang laman nito, mga element ni X. Okay? Ang laman nito, mga element ni X, such that lahat ng Y na yon, yun yung ka-related kay X. Lahat ng ka-related kay X. Okay? Ang capital X over R naman, or sometimes tinatawag natin siyang X modulo R. So, ang capital, so ito equivalence class, X, ito, X modulo R. So, itong set na to, ang mga laman niya, mga equivalence classes. Okay? So, lahat ng equivalence classes ni R, yun yung laman ng X modulo R. Lahat ng equivalence classes ni R. Okay? So, these are, given na this R is an equivalence relation, then small x over R is called the equivalence class determined by X. So, meaning, kung iba yung X, pwedeng iba yung equivalence class. On the other hand, capital X over R or X modulo R is the set containing all equivalence classes in R. Or, in short, we call it the quotient set of X over R. Okay? Quotient set of X over R. Kaya, ang notation natin, parang X over R. Again, hindi ibig sabihin nito, dinidivide natin yung X by R. This is a symbol. Symbolic lang ang gamit natin dun sa slash symbol. It doesn't necessarily mean the division symbol. It just means that we are using it as symbol to denote X modulo R. To denote the set containing all equivalence classes in X determined by small letter X. Yeah. Okay. So we have the following properties. So let R be an equivalence relation on X. Then we have the following. Each X over R is a non-empty subset of X. X over R intersection Y over R is empty whenever is not empty whenever X and Y are related to each other, and X is related to Y if and only if XR is equal to YR. Okay. So first, before we prove, let me just illustrate the properties bago natin i-prove ha. Pakita mo natin ano ibig sabihin natin dun sa property na to. Para lang mas maintindihan natin. Okay. So let's say we have the modulo relation. For the purpose of discussion, magbigay ako ng specific M. So let's say modulo 7. Okay. So, pag sinabi mong modulo 7, congruence modulo 7, ang ibig sabihin nun, X is congruent to Y modulo 7 if and only if X minus Y is congruent, is equal to 7n for some n. So, there exists an n such that X minus Y is a multiple of 7. Yan ang ibig sabihin ng modulo 7. Okay? So kung mapapansin natin, ano yung ibig sabihin ng in this relation? Ano yung ibig sabihin ng X over the modulo relation? So ang ibig sabihin niyan, ito yung lahat ng set, okay? Ito yung set containing lahat ng Y doon sa integer set natin such that si Y ay congruent kay X modulo relation. Yan. Ay, modulo 7. Modulo 7. Okay? So, for example, 2 modulo relation. Okay. 2 over modulo relation. Ano ibig sabihin nun? Ang hinahanap natin ay lahat ng y such that ang y congruent sa 0 mod 7. Sa 2 mod 7. So, ano laman nung 2 over modulo relation? So, ang laman niya, lahat ng y minus 2 equals 7n. Meaning, lahat ng y na equal sa 7n plus 2. Yun yung laman ni 2 over modulo relation. Okay? So, ano laman niya? So, lahat ng x na congruent or lahat ng y na congruent kay 2. Or ibig sabihin, lahat ng y that can be written as 7n plus 2. Ede, madali nang compute niyan. Substitute ka lang ng n. Okay? So, ano mga laman niya? So, negative, for example, pag ang n ay negative 1, edi negative 7 plus 2, negative 5. Pag ang n ay 0, edi 2. Pag ang n ay 1, edi 9, and so on. Actually, plus 7 ka lang ng plus 7. Yan. So, 9 plus 7, 16, and so on. So, yun yung laman ng 2 over modulo relation. Okay, so hindi siya empty. Kahit anong x ang gamitin mo, laging may laman yan. For example, kuha pa tayo ng isa. Let's say, kumuha ako ng ibang number. Let's say 24. 24 over modulo relation. Ano daw yung laman niya? Ang laman niya, lahat ng y na integer such that y is congruent this time sa 24. Okay? Modulo 7. Okay, so ano laman yan? So ang laman yan, lahat ng y minus 24 equals sa 7n. Or lahat ng y that can be written as 7n minus 24. Plus 24 rather. O, sulat natin mga laman niya. Ano laman ng set na to? Pag ang n ay negative 1, Pag ang n ay negative 1, 7, this should be 24, mukhang n. So, negative 7 plus 24, 16. Pag 1, 24 plus 7, and 30, pag 0 muna pala. Pag 0, pag 1, 7 plus 24, 31, and so on. Well, kung makapansin nyo, yung 2 over modulo relation, tsaka 24 over modulo relation, modulo 7 to Lagyan ko na sa 7 para sure. Kasi madaming modulo May modulo 1, modulo 2. Depende sa M. Ayan. So 24 modulo 7, may 16 siya. Yung 2 over modulo relation, may 16 din. Well, actually, pagka tinuloy-tuloy ko yung value nito, halimbawa negative 2. 24 minus negative 8 lang. Tama ba? Parang mali yung mali yung value ko. Dapat 23 ang ginamit ko. This should be 23 para maging equal. Sorry for that. It should be 23. 23. So this is 30. Yan. Yan ang tama. Okay. So ulit. 23 modulo 7 is y minus 23 equals 7n. So that's y equals 7n plus 23. So ang mga laman niya 16, 23, 30. Pero kung itutuloy natin yung value niya, let's say negative 2. So negative 14 plus 23. That's actually 9. Tapos negative 3. So negative 21 plus 23 is 2. Pag negative 4, negative 28 plus 23, negative 5. So basically, these two are the same. Kung nakita natin dito, yung 2 over modulo relation, tsaka yung 23 over modulo relation, as a set, pareho lang sila. They're equal. Kung nalilito kayo sa notation na to, you can keep this notation. Ayan. Baka kasi nalilito kayo dun sa notation na over modulo relation. Minsan nakakalito talaga siya. Minsan nakakalito. Lalo na kung naninibago ka pa na ginagamit natin yung operation symbol or relation symbol na modulo relation in a denominator. Pero well, again, technically, hindi siya denominator. Huwag niyo isipin as denominator. Symbol lang naman siya. Okay? So, as a set, yung dalawa na to, equal lang daw. Okay? So, nung nakakita tayo ng intersection, eventually, we were able to show na equal lang naman pala sila. Okay? Isa pa, yung 2 tsaka 23, they are actually related. 2 minus 23 is actually negative 21, which is times negative 3. Therefore, ang ibig sabihin nun, yung 2 related sa 23. Okay? So, anong pinakita natin doon sa example natin na to? Ang napakita natin sa example na to, precisely these three properties. Kada isang x over r, lagi siyang may laman. It's always non-empty. And pag yung dalawang equivalence class ay hindi empty ang intersection, meron siyang common element, automatic yung x at y related sa isa't isa. As shown nung 2 tsaka ng 23. And finally, pag ang x at y related sa isa't isa, ultimately, yung dalawang equivalence class, equal lang. Okay, so let's prove that. Again, yung magpapakita ng example, parang maintindihan natin yung ibig sabihin niya. Somehow, parang familiar na tayo sa konsepto na yun. Somehow, medyo alam natin ipakita yung konsepto na yun if you have specific example. But ultimately, of course, we want to show it in general. So we want to prove those three properties. Okay, so let's prove that each XR is non-empty subset of X. Okay, given that R is an equivalent relation, we know that R is reflexive. Kasi equivalent relation siya. So reflexive siya. Okay. So kung reflexive siya, ang ibig sabihin nun, kada isang X for every X in capital X, XRX. Kung isa yun sa XRX, ibig sabihin nun, yung ordered pair XX, alright, ay nasa relation. Or X is related to itself. Okay. So if X is related to itself, so X related dito. So yung unang X dapat ay element nung X over R. Kasi by definition, ibig sabihin ng X over R, lahat ng element, di ba? Ang X over R, lahat ng element ni X such that si Y related kay X. Oh. Sabi natin na X related sa sarili niya. Di ang X nandun sa set na yun. Tama? So dahil yung X nandun sa set na yon, ang ibig sabihin, may laman siya. So we were able to establish that X over R is not empty. Okay? So we're good with property number 1. Okay. Now, how can we show that whenever the intersection is not empty, X is related to Y? So next property. Ang given X over R, the equivalence class, intersection, equivalence class Y over R is not empty. Okay, so kung hindi siya empty, ang ibig sabihin nun, may common element. Tama? Sabihin natin si Z yung common element. So let's see be the element common to both X over R and Y over R. So Z is an element of X such that, ano ibig sabihin? So nandun siya sa X over R, and at the same time, nandun din siya sa Y over R. Kasi nasa intersection siya ng dalawa eh. Okay? So, ano ibig sabihin pag yung C nandoon sa X over R? Ang ibig sabihin nun, si C related kay X. And, syempre, si C related din kay Y. Well, because R is an equivalence relation, it must be reflexive. Ibig sabihin, pag meron kang C related kay X, edi dapat si X related din kay C. So, we're keeping this one, C related kay Y. Again, because it is reflexive. Right? Next, if X is related to Z and Z is related to Y, then by transitivity, X must be related to Y. Right? Which is what we want to show. Okay. So we are done here. Okay? So nakadalawa na tayo. We've shown that whenever the equivalence class has an intersection, then the equivalence class represented by x and y are related. So x is related to y. Now, the third property that we want to show is that if x is related to y, then the equivalence relation must be equal. The equivalence classes rather. If x is related to y, then the equivalence classes must be equal. So given that x is related to y, ang gusto natin ipakita that two equivalence class, remember what we want to show is that x over r must be the same as y over r. So as an equivalence class or as a set, dapat pareho sila. Okay? So this is basic application of set equality. Paano ba natin pinapakita na ang dalawang set ay equal? So all we need to do is to show that every element of the first set is an element of the second set. Okay? Okay. So, meron na tayong x at y. So, hindi ko na pwedeng gamitin yung x at y. Z naman. So, let's see be an element of x over r. Ano ba ibig sabihin? Pag C element ng x over r. Well, by definition, ang ibig sabihin yan, di ba? C is related to x. Tama? Ibig sabihin, C is related to x. Okay. Pero, ang given natin, si x related kay y. So, pag ang c ay related kay x, tapos ang x ay related kay y, sabi ng given, ang ibig sabihin nun, si c must be related to y. That's the given. Right? Well, if c is related to y, ano ibig sabihin nun? If c is related to y, edi si c ay dapat nasa y over r. So, lahat ng laman ni x over r, laman din ni y over r. Right? Now, similarly, by symmetry, kasi ang napakita lang natin dito, ang x over r ay subset ni y over r. So, paano mapapakita yung kabila? Similarly, di ba? Pag ang c ay element ni y over r, then by the same definition, si y ay related, or rather, si c ay related kay y. But, ang given natin, x is related to y, but since r is in an equivalent relation, it must be symmetric as well. So, ibig sabihin nun, pwede mo rin ipakita na yung x related to y ay y related to x by symmetry. And then finally show that c is related to, wait lang, dapat maging, yes, c is related to x. Yan. Or meaning, if c is related to x, then it must mean that c belongs to, ano to? C is a subset of x over r. Ay, element rather. Element. C is an element of x over r. Now, ang assumption natin dito ay x related to y. Ang napakita natin, x over r is equal to y over r. The property is an if and only if statement. Mapapansin niyo, the property is an if and only if statement. So we also need to show the other inequality, rather other implication. Pag given ito, dapat mapapakita mo na ang x, r, y. Kanina pala, if and only if din, no? So nakalimutan ko sabihin yung if and only if kanina. So ito yung given, pero ito, ang intersection empty, this is an if and only if statement. Kasi definition lang yan ng intersection being not empty. Now, these two, ito, definition nito, Ito, definition nito. So, this is also an if and only if statement. Now, this and this are equivalent statement. Kasi, reflexive siya. So, that's the definition of reflexive property. So, if and only if din yan. Pero pag merong anong dalawa na to, this is an if and only if because of the transitivity. Okay? Now, dito naman, let's take a look at the other implication. Pagka daw si x over r equal sa y over r, dapat mapakita mo na ang x related kay y. Okay? Dapat mapakita mo na ng x, well, that's easy to show. Bakit? Kasi ang x over r, pag equal siya sa y over r, edi yung x over r intersection y over r, obviously not empty. Kasi equal eh. Tama? Edi kung hindi sila empty, by the second property, ano ibig sabihin? Edi x is related to y. Okay? Ganyan lang. Kailangan lang natin i-consider yung other implication. So therefore, the three properties hold. And as we see in the example, it is indeed true, di ba? Okay. So let me have a remark. Let R be an equivalence relation on X. The elements of X that are related to each other belongs to the same equivalence class. Kamukha nung nakita natin kanina, yung 2 chapter 23, they belong to the same equivalence class whenever the two elements are related. So meaning, kung ano mapakita natin, may mga element that belong to the same equivalence class. So, two equivalence class, whenever they have a common element, will become the same equivalence class. So, ibig sabihin, kung ang dalawang equivalence class ay walang element, walang common element, then they become mutually disjoint. Tama? So, if we consider only those that are mutually disjoint, so we were able to determine the unique equivalence classes. Unique equivalence classes in X. So pag pinagsama-sama mo na yung mga unique equivalence classes na yun na yung capital X over R. Let's have a more vivid example. So let M, yung kamukha nung kanina example, let M equals 3. The equivalence class of the congruence relation modulo 3 are the following. So again, in symbol, ang equivalence class 0 over. Okay. So 0 over. So ano ibig sabihin ng 0 over modulo relation mod 3 natin? So these are the element of Z such that X is congruent, yung definition nito, XR. So X is congruent to 0 modulo 3. Now this is already a familiar set, di ba? Siya na yung set natin kanina, yung 3n for all n element of C. Or in our notation, that's 0 bracket 3. Similarly, 1 over modulo relation is the set containing all x element of C such that x this time is congruent to 1 modulo 3. Tatandaan nyo kung paano fino-form ha yung set. Again, x over r is equal to, ginamit ko dito yung x, so gamit ko ito y. Or a na lang, para hindi kayo malito. So, all x in capital X such that x is related to a. Yan. Yun yung iniipon mo. Yung r natin is defined by the modulo relation. So, ito yung definition ng r natin. Okay? But, again, this is just the set 3n plus 1 for all integers z. Or, in our notation, 1 bracket rather. 1 bracket sub 3. And finally, this set here is all element x such that x is congruent to 2 modulo 3. And that's 3n plus 2. Or in our notation, that's 2 bracket sub 3. So, ibig sabihin, ang mga equivalence classes pala ng we know that there are no other. Wala nang ibang set sub 3. Yung 0 lang, yung 1 lang, tsaka yung 2. So, pag kinuha mo yung 3, mapapansin mo, pag kinuha mo yung 3 modulo sub 3, that's the set X element of C such that X is congruent to 3 mod 3. Well, basically, what you're doing is you're getting the set 3n plus 3 element of C. But 3n plus 3, we can easily show that's the same as the 0 bracket 3. Okay? So, pag kinuha mo yung lahat ng element X, 0, 1, 2, 3, 4, 5, tapos in-over modular relation siya, paulit-ulit na makukuha mo lang yung tatlong set 0, 1, 2. So, meron lang tatlong distinct equivalence class modulo 3. Ano-ano yon? So, yung tatlong distinct modulo C in this case, over the modular relations sa 2. These are sets ha. Huwag malito. These 3 are sets. Itong tatlo na to, set yan. Set 1, set 0, set 1, set 2. Uulit na siya, kaya tatlo lang yung distinct. Kasi uulit na. So we have 3 distinct equivalence class. Now, I want to point out at this point, yung tatlong equivalence class na to, this is also a partition. Napakita natin kanina, di ba? This is a partition of C. So, una, meron tayong relation R. Nagsimula tayo sa relation na modulo. Yun yung relation natin. Nakakuha tayo ng tatlong equivalence classes. Ano yung tatlong equivalence classes? Yung equivalence class 0, equivalence class 1, saka equivalence class 2. Tapos nakita natin na yung tatlo na yun actually comprise a partition of Z. Napakita natin kanina na these 3 are partition of Z. So yun yung connection. Yun yung connection ng relation into partition. Napakita natin that whenever we have a relation, but actually now to simplify our notation, yung x, itong x over modulo relation M, susulat na lang natin siya as x bracket M. Para di tayo nalilito doon sa notation na to. Again, ito pa rin yung equivalence class na x over r ha. Here, r is the modulo relation. Yun pa rin yun. Kaya lang, we want to, as much as possible, simplify our notation para mabilis nating na-identify yung set. Okay? So, we will simplify the notation x over equivalence only for this, x over modular relation to be the x bracket M. X bracket M. Kasi nakita natin na equal lang yung dalawang set na yan. Okay? So, this is a very convenient notation. Similarly, in number theory and abstract algebra, meron tayong ganitong quotient class. Yan. Actually, itong modular relations na to can be induced by this set NC. Ano yung NC? This is actually the set that leaves a remainder 0. When you divide or all elements of this set leaves the remainder 0 when you divide by n. So from here on forward, we can use a simple notation for this as C sub n. So here, C sub n is nothing but the set containing the this is bracket n, 1 bracket n, and so on, up to n minus 1 bracket n. So the equivalence, the x modulo R relation natin can be written this way in terms of the modulo relation. So pag modulo relation yung given, so ang modulo dito n. Okay? So yung z sub n na ginagamit niyo sa abstract algebra or sa number theory, gagamitin pa lang pala, wala pa kayo number theory. Yung gamitin sa number theory is actually precisely the collection of the modulo class C modulo relation. Pero syempre, in number theory, ang gagawin niyo na lang notation dyan, this is in number theory. In number theory, ang gagamitin niyo na lang dyan, 0, 1, 2, up to n minus 1. These are actually the remainders. Okay? So, in number theory, tinitingnan nyo lang siya as remainder. Pero here in set theory, tinitingnan natin siya as the collection of the set. The collection of the set that leaves the same remainder when you divide it by n. Okay? So, yun yung connection ng dalawa. Yan. Okay? Sige. So, as I've said a while ago, this set actually forms a partition. So, napakita natin in 3, in m equals 3. But in general, you can easily show that in any arbitrary value of n. So, yung Z1, C2, C3, C4, and so on, for any value of n, actually produce a partition of Z with respect to the modulo relation. Okay, with respect to modulo. Okay, so let R be an equivalence relation on X. Then, the quotient set X over R is a partition of X. So, in general, so generalize lang natin yung nakita nating observation. This is always true. Whenever you have an equivalence relation R, then this particular R will always induce a unique partition of X. And this partition of X is exactly the quotient set X over R. Okay? Again, ano yung quotient set X over R? X over R is the collection of all the equivalence classes, the distinct equivalent classes that is determined by the relation R. Okay? So sa example natin kanina, yung C over the relation mod 3, so tatlo yung equivalence classes natin, equivalence class ni 0, ni 1, tsaka ni 2. Lahat yan sub 3. Sub 3. Okay? So let's prove that in general. So observe natin na yung family natin, sulat natin yan, observe that the family X over R, again, this is a collection, collection siya ng mga equivalence classes. So let's observe that this collection is non-empty. Okay? We've already established that. Laging may laman yan. So this is non-empty. So all we need to do is to show that this is actually a partition. Okay, so dalawa yung requirement para mapakita natin na partition. Remember, what we want to show is that first, this is mutually disjoint. Ano ibig sabihin ng mutually disjoint? Pag kumuha ka ng dalawang partition, dapat empty yung intersection. Pagka two distinct partition yan. And second, we also want to show that all the elements are here in the partition. So the union of all x over r for all x must be the entire set x. So yan yung dalawang gusto natin pakita para masabi natin na yung x over r indeed is a partition of x. Okay. So isa-isay natin. So that's what we want to show. So number 1. Gusto natin mutually disjoint. So let's say meron tayong two partition that are not equal or two elements pala ng partition. So let's say we have the equivalence class XR and the equivalence class Y over R to be two distinct partition. So yun yung ibig sabihin ng distinct partitions. Okay. So since what we want to show is that these two partitions are empty, let's show on the contrary that they are not empty. Okay? So suppose, ang gusto natin pakita, empty yan. Suppose hindi siya empty. Suppose x intersection r, x over r intersection y over r, sabihin natin may laman siya. Okay? So sabihin natin hindi siya empty. Okay. So we're proving by contradiction. So ano ibig sabihin kung may laman siya? Or hindi empty yung intersection? So it follows that kung hindi empty yung dalawa na yan, by our property, automatic ang x related kay y. Tama? Sabi ng property number 2 natin kanina, automatic ang x related kay y. Pero pag ang x related kay y, ito ang ibig sabihin nun, si x over r must be the same as y over r. Tama? Again, these are the properties of x over r. Oh, akala ko ba ang assumption is distinct? So this is a contradiction since by the given, dapat ang x over r ay not equal to y over r. Kasi yun yung given. Or, well, hindi given, assumption. So since this is a contradiction, therefore, the assumption na ito ay hindi equal must be false. So therefore, ang totoo, XR intersection YR is empty. So whenever X is not equal to Y, or the equivalence relation, or the equivalence class rather, whenever the equivalence class X over R is not the same as Y over R, then their intersection is empty. So mutually disjoint. Okay na tayo dun. So we're okay with this one. So number 2, we want to show that when you get the union of the entire collection, you get X. Alright. Now, obviously, X over R must be a subset of X. Tama? Kasi by definition, di ba? By definition, ano ba tong X na to? Yung X over R is simply X element of X, or rather, all Y element of X such that Y is related to X. So kung may laman itong X na to, kung may laman siya, ang mga laman nun, laman din ni X. Kaya automatic subset siya ni X. So there's no question there, ha? Si bawat isang equivalence class, laman siya ni X. Okay. So, ibig sabihin nun, automatic na pag ni-union mo lahat yan, kung ano mo union, subset siya ng X. Okay? So, yung union ng lahat ng equivalence classes, automatic subset siya ni X. There's no question there. Kasi bawat isang equivalence class, ay laman ni X. So, pag pinagsama-sama mo lahat yun, syempre, naka-X pa rin yan. So, ang kailangan lang natin ipakita talaga, yung kabaligtaran, na yung X nasa laman din ng union. Okay? Pero kung mapapansin natin by definition, so, okay na tayo sa isang direction, ha? So, yung kabila na lang. Now, kung papansinin natin, for every X in the capital X, di ba, by the property, X must be an element of X over R. That's the first property, di ba? Pinakita natin ng X over R is not empty because X is always in the equivalence class X over R. So, kada isang laman nitong X ay nandito sa equivalence class nito. Pero syempre, lahat ng equivalence class na to nasa union. This is a subset of the union X over R. Pagsasama-samahin mo lang lahat ng equivalence class eh. So, kada isang element ng X ay nasa equivalence class at kada isang equivalence class nasa union. O di ano ibig sabihin nun? O di yung X subset ng union. Okay? Yung X subset ng union, which is precisely the definition of the partition. And so we are done. Okay na? Kasi napakita natin na yung union is the same as X. At each element of the partition is mutually disjoint. Okay? So again, this is true for any equivalence relation R. So kada isang equivalence relation R, nag-i-induce daw siya ng partition ng X. Which is precisely yung example natin kanina. Di ba? Yung example natin kanina, meron tayong equivalence class defined by the modular relation mod 3. So, nung kinuha natin yung equivalence class ng mod 3, nakakuha tayo ng tatlong equivalence classes. Yung 0 mod 3, 1 mod 3, tsaka 3 mod 3. So, 2 mod 3. Itong tatlo na to. So, yung tatlo na yan actually forms a partition of C. So, this is the partition induced by the modular relation mod 3. In general, for any number n, for any natural number n, the modular relation n will induce the partition 0 mod n, 1 mod n, up to n minus 1 mod n. And those are the n distinct equivalence classes induced by modulo n. So, by our theorem, these modulo classes or equivalence classes actually form a partition of Z with respect to modulo n. Okay? With respect to modulo n. So, ganun lang kasimple. Pagka ang n equals 3, ang equivalence classes mo eh 0 mod 1, 0 mod 3, 1 mod 3, tsaka 2 mod 3. Pag ang n equals 4, ang equivalence classes mo, 0 mod 4, 1 mod 4, 2 mod 4, 3 mod 4. Pag 5, ganun din, 0 mod 5, 1 mod 5, 2 mod 5, 3 mod 5, 4 mod 5. In general, 0 to n minus 1 mod 5. In the language of number theory, ang ibig sabihin nun, that's the remainder when you divide by n. Okay? So, yun nga yung binanggit ko kaninang example. Yung example natin. So, you can generalize that. That's easy to generalize and to show na pwede mong kunin yung equivalence class determined by the modular relation. So, okay na. Pagka modular relation, hinanapan kayo ng equivalence classes, bigay nyo lang yung zero bracket n natin. Yun na yung equivalence classes. Now, balik na rin naman natin. So, dito, nauna yung relation, then nakakuha tayo ng partition. Actually, the other one can be done as well. Paano kung meron kang partition? Then, can we define it as a relation? And that's actually the case for this one. So, let script T be a partition of a set X. Using this partition, we will define the relation induced by this partition. And this will be denoted by capital X over T. So, ito na naman yung notation ng X over T. So, again, this is just symbolic. So, this is a relation. Okay, tandaan nyo this is a relation. So, paano mo i-define yung relation na yon? So, this relation is defined by this definition. X is related to Y if and only if there is an element of the partition such that X and Y belong to the same set. Okay, medyo alam ko medyo mabigat na yung definition. Unti-unti natin. In other words, ang ibig sabihin niyan, X and Y are X over T related if and only if they belong to the same set in the partition. Okay? Simplihin natin. Lagyan natin ng example para mas maintindihan mabuti. So, let's say meron akong set. Okay. So, since familiar na tayo sa set Z, let's say yung Z, hahatiin ko sa tatlo. Hahatiin ko siya sa set containing negative elements, so negative 1, negative 2, negative 3, and so on. Lahat ng negative. Tapos yung isang set, lahat ng positive. Positive 1, positive 2, positive 3, and so on. And of course, the other set, simply the set 0. Okay? Ayan. So, nakakuha ko ng isang partition ng Z. Ano yung partition na yon? So, tawagin ko tong Z minus, tawagin ko tong Z plus, okay? Tapos tawagin ko tong 0. Ayan. So, the set containing C minus, the set containing the 0 element, and the set containing the positive integers. So, that's a partition. Right? This is a partition. So, let's call this partition, mali yung notation ko. C is equal to, let me correct the notation, the union and the union. Yan yung C. So, yung partition ay yung elements niya, yung mga subset na yan. Yung C negative, yung 0, tsaka yung C positive. Okay? Yan. Okay. So, this is a partition. Is a partition. Now, paano natin i-define yung relation induced by the partition T? So, yung relation natin is X over partition T. So, this is the partition induced. This is a relation induced by the partition. So, naunang given yung partition, ha? Tapos, i-define lang natin yung relation X over T induced by T. So, paano natin i-define yan? So, ang X daw ay related kay Y if and only if there exists a set in the partition such that si X, Y both belong to the same set. So, magiging related lang sila if they belong to the same set. For example, ang 0 at ang 1 are related. Bakit? Because they do not belong to the same set. Pero ang negative 1 is are related to negative 2. Since negative 1 and negative 2 belongs to the same set, which is C minus. Right? Similarly, ang 4 is related to Y. To 5. Since 4 and 5 belongs to C plus. Right? Okay na. Napakasimple namang maintindihan ng concept. Okay? Baka nabigla lang kayo sa definition. So, ang X related to Y using the relation induced by the partition T. So, medyo mouthful na kasi sabihin na X is X over T related to Y. Medyo mouthful. Pero yun nga, ganun nga talaga sabihin siya. So, X, so kung gagamitin mo yung notation na to, X is X over T related to Y. Okay? Alin yung X over T? Yun yung induced relation. Induced by what? By the partition T. So, nauna yung partition T, tapos in-induce niya yung relation R. Okay. Now, let's connect now the induced relation. So let T be a partition of X. Then the relation X over T, again, this is the induced relation or the relation induced by the partition. So let X over T be the relation induced by the partition. This is actually an equivalence relation on X. And then the equivalence classes induced by this relation is precisely the partition T. So, dalawa yung kinlaim ng theorem. Una, yung relation na to, this is actually an equivalence relation. Okay? So, equivalence relation siya. Pangalawa, dahil isa siyang equivalence relation, sabi nung naunang discussion natin, mag-i-induce siya ng partition. Tama? Kung naalala niyo pa, lahat ng equivalence relation, nag-i-induce ng partition. At pag kinumpute mo yung i-induce na partition, that's precisely, ang makukuha mo precisely, yung mismong T partition na na-induce nung induced relation. So, meron kang partition, mag-i-induce siya ng relation. So, yun yung ano, meron kang partition, i-induce niya yung relation. Okay? I-induce niya yung relation. Yung relation na to, mag-i-induce ng partition. So, paano natin ilagay yung notation? Di ba ang notation niyan is, dito lang sa baba. X over the relation X over T. This is a relation ha, this is a relation. Yan, para di kayo malito. So, ito yung induced partition, yung equivalence classes. So, ang sinasabi nito, the induced partition is actually the same as the partition. Yan. Induced by T. Ito, induced by X over T. So, kailangan maingat kayo dun sa notation nyo, ha. Ulitin natin. Meron akong partition. Okay? In-induce ko yung relation na to. So, this is a relation. Ang unang statement, equivalence relation daw siya. So, that's number 1. Number 2, since equivalence relation siya, mag-i-induce siya ng partition. Aling partition yung i-induce niya? Ito. Yan yung i-induce na partition ng X over T. Ang sinasabi ng theorem, equal lang din siya sa original partition. Okay? Yan. So, that completes the relationship between the partition and the induced relation. Now, again, ang basic example natin dyan, yung kanina pa natin example na modular relation tree. Kung mapapansin nyo, yung modular relation tree, originally, we started with the partition. Di ba? Pinartition natin siya, 0. Oh, let me show it again. Pinartition muna natin siya. Dito tayo nag-start sa partition na 0 mod 3. Ayan. Ito na una natin eh. 0 mod 3, partition. 1 mod 3 and 2 mod 3. So, this forms a partition of C. Itong tatlo na to. Now, if we define a relation induced by this partition, ano i-define natin yung relation? So, the relation will be, they will be related if they belong to the same set. Pero, paano ba sila mabibelong to the same set? If they leave the same remainder as 0 for 0 bracket 1, bracket 3, as 1 for 1 bracket 3, and if they leave a remainder 2 for 2 bracket 3. Pero that's equivalent to the modular relation mod 3. Di ba? So, ang sinasabi nito, yung partition mo, for every partition, meron kang i-induce na unique relation. For any relation, meron kang i-induce na unique partition, and those two are induced by each other. They were being induced. So, pag nagsimula sa partition, nag-induce ka ng relation, yung relation, in-induce may partition, you'll go back to the same partition. Pag nagsimula ka sa relation, nag-induce ka ng partition, yung partition, in-induce mo yung relation, that relation induced by the partition is the same relation that induced this partition. Paikot-ikot lang, di ba? Okay. I hope that's clear. But, we still have to prove, of course. Yan. So, yun yung sinasabi ng theorem. Again, dalawa yung ipoprove natin, ha. First, that it is an equivalence relation, and second, that the induced partition is induce the original partition. The induced relation rather. Okay, nabubulol na ako sa induce na to. Okay, sige, simulan natin sa equivalence relation. Again, tatlo yung kailangan mo ipakita para masabi natin na yung R, which is the induced relation X over T, is an equivalence relation. Ano yung tatlo na to? Reflexive, symmetric, tsaka transitive. Simulan natin ipakita na siya ay reflexive. Since T is a partition, right? Then for any X in our original set, okay? So just to have a pictorial representation, meron kang X, hinati-hati mo siya. So yan yung partition mo. Let's say meron kang T1, T2, T3, T4, and so on. So basta meron kang set dyan. So for every X in our partition, for every X in our set, yung original set natin, yung capital X, dapat makakakita ka ng set A sa partition natin such that X is in that set. Tama? Such that X is in that set. So isa dyan yung A. Again, that's just a naming convention. So basta isa dyan sa mga T na yan yung A. So again, kasi partition siya eh. So lahat ng element ng X dapat nandun. 'Di ba? Dapat may isang member ng partition na nagko-contain ng kahit anong element ng X. So any element of X, you can always find a set A in the partition such that X is in A. Now, technically speaking, if X is in A, then ibig sabihin nun, di ba, both X and X is in A. Addition rule lang ng logic, di ba? X is in A, then X, the same element is in A. Pero that means that in our definition, X must be R related to X. Tama? X must be R related to X kasi they belong to the same set in the partition eh. That's the definition of the induced relation. O, ibig sabihin yung X over T is reflexive. Ayun na ibig sabihin. Next. Ang sunod, symmetric. So, pag symmetric, dapat meron kang dalawang element. So, let's say we have X and Y to be an element of the capital X such that X is R related to Y. So, X is R related. So, X over T related to Y. Ano gusto mong pakita? Gusto mong pakita na si Y R related din kay X. Okay. Pero if X is R related to Y, edi ang ibig sabihin nun, by the definition of the induced relation, dapat makakita tayo ng set A in the partition T such that si X tsaka si Y nandoon kay A. Right? Well, in set, syempre kung ang XY na kay A, dapat ang YX na kay A din. Right? Membership of set naman, it doesn't matter kung ano sinulat mo ng una eh. XY is the same as YX. So if YX is in A, by the definition of the induced relation, na una yung Y, so yung Y ay R related. So X over T related kay X. Which is what we want to show. So therefore, this is symmetric. Therefore, X is X over T, capital X over T is symmetric. And finally, if we want to show transitivity, so kailangan natin dalawang element pag magpapakita tayo ng transitivity. So if X, Y, tatlo pala rather, dalawang relationship. So if X, Y, Z are elements of X such that si X ay R related kay Y, so X over T related to Y, and si Y are related kay Z. So, X over T related kay Z. Ang gusto natin pakita, si X at C din are related. Well, by definition of the induced relation, this must mean that both X and Y, there must exist an A element of tau such that X and Y is an element of A. Now, dito mag-iingat tayo Ang ibig lang sabihin ng XY, X related to Y, may set that contains both of them. Ang ibig sabihin ng YC, may set that contains both of them. But it doesn't mean that these two sets are the same. Hindi ibig sabihin pareho yun, ha? Basta ang sinasabi lang, there must exist a set. So, kailangan natin ng isa pang set para dun naman sa pangalawang relation. So, B is in the partition such that this time YZ is in the set B. Yan. Again, hindi automatic na same set yung pinag-uusapan natin Basta ang sinasabi lang, there exists. Pag sinabi mong there exists for some. So, hindi naman sinabing unique. So, there exists an element of the partition, let's say A, such that yung XY na kay A. There exists another element of the partition, let's say B, such that yung YC nandun kay B. Okay. Pero yung XYZ, those are three distinct elements of capital X. Three distinct elements. Okay. So, if we have this and this statement, this is an end. Ano ibig sabihin nun? X, Y is in A and Y, Z is in B. The Y is in A intersection B. Y is in A intersection B. Si A elemento ng partition. Si B element din to ng partition. So meron kang A intersection B na hindi empty. Nasa partition tayo. Ano sabi ng partition? Imposible na meron kang A intersection B ng dalawang distinct na set na nag-overlap na may intersection. So ibig sabihin, kung hindi empty yung intersection, automatic equal sila. Tama? Kung hindi distinct. Kasi sa partition, hindi pwedeng nag-overlap ka lang Dapat either equal ka o disjoint ka. Nag-overlap sila. So, ibig sabihin, equal ka dapat. Hindi pwedeng may laman si A na hindi din laman ni B. So, automatic, in a partition, if the intersection is not empty, automatic, they are the same set. Okay? So, if they are the same set, ano ibig sabihin nun? So, X and Y belong to the same set. And Y and C belong to that same set. So, ibig sabihin, both X, Y, and C belongs to A. Well, either A to B, equal lang din naman sila. If X and C belong to the same set, then they are related. Tama? So, X is XT. Sorry. X is X over T related to C. Yan. Wala nang ibig sabihin nun. Hindi transitive siya. Tama? Therefore, yung partition, yung relation na X over T is transitive. So, transitive, symmetric, and reflexive. Therefore, it's an equivalence relation. Okay na. Equivalence relation na siya. Okay. So, if it's an equivalence relation, then it must induce a partition. Okay? Since equivalence relation siya, sabi nung previous kanina, it should induce a partition. Okay na? So, ang kailangan na natin i-show na yung partition na i-induce nito is the same partition as T. Okay? Yung second part. Okay. Now, for a given element, so let us now show that these two partitions are the same. So let's take an element of X. So the second part, the two partitions are the same. Alin yung two partitions? Yung partition T, tsaka yung partition na in-induce. So equivalence classes induced by this relation. Yan. X over R yan X over R. Equivalence classes. Okay. So, given an element X, there always exists. Now, I will claim that this is a unique A in T such that X is in A. Bakit unique? Kasi partition nga eh. As I mentioned a while ago, hindi pwedeng ang X ay common sa dalawang magkaibang element ng partition. Tama? Hindi pwede. Pag may overlapping na ang dalawang partition, automatic that's the same partition. So X cannot belong to more than one set in the partition because the partition is mutually disjoint. Okay. So anong ibig sabihin nito? So ibig sabihin nito, so for this particular A, so X over XT. So ano yan? Ito yung R ha. Sige na, isusulat ko muna as R baka kasi nalilito tayo sa sobrang daming mga over. So X over R, this is the equivalence class containing X. This must be the same as A. Tama? That must be the same as A. Bakit? Alam natin na this is a set which is a subset of X. Tama? Okay. So this set is a subset of X. So if it's a subset of X, on the other hand, A is also a subset of X. And A belongs to the partition T. Now, ang sabi natin, no matter what happen, yung mga partition mutually disjoint. So, ibig sabihin, itong X na to, it cannot belong to other set belonging to this partition. Hindi pwedeng may iba pa siyang hindi pwedeng may iba pa siyang set kasi magiging A lang din lahat 'yon. Yan. So ultimately, kahit anong element nito ay member lang ni A. Kahit anong laman nito. On the other hand, lahat ng laman ni A ay X-related. 'Di ba? For any Y element na A, lahat 'yon X-related. Lahat 'yon ay YRX. Bakit? Kasi nga ang definition nung R natin ay lahat nung belonging to the same set, magkaka-related. Okay? So, lahat ng laman ni X over R na kay A. Lahat ng laman ni A ay Y ay related kay X. Pero lahat ng related kay X must belong to X over R. Tama? So, A is a subset of X over R. So, ito ay subset ni A at ito ay subset ni X over R. So, equal sila. Okay? So, ayan. Okay, so okay tayo dito ba? So, X over R is equal to A. So, meaning, kahit anong kunin mo na X, yung equivalence class na to, ay isa sa mga partition ng T. Nakuha niyan? Kahit anong equivalence class, ay isa sa mga partition ng T. Well, saan ba member si equivalence class? Si equivalence class ay member ng equivalence class na induced nito. Tama? Si A ay member ng partition T. So, meaning subset sila. Okay? Clear yun, ha? So, dahil lahat ng equivalence class ay isa sa mga partition, isa sa mga element ng partition, then yung buong collection ng equivalence classes ay subset ng partition. Okay, lahat ng element ng equivalence classes, element ng partition. Paano naman yung pabaligtad? So, yung pabaligtad naman, so kung meron kang A na hindi empty, na subset ng partition, right? Then, since A is not empty, meron kang makikitang X, element ng X such that X is in that A. Okay. Ano ibig sabihin nun? So, ang ibig sabihin nun, si X over R is equal to A. Now, same reason natin kanina. So, yung X over R, magiging A. So, this is an equivalence class. So, yung A natin is an equivalence class. So, everything na laman ng partition, baliktad yung baliktad lang. Yung logical sense lang, kaya ako binaliktad. Lahat ng laman ni partition ay isang equivalence class. Right? Lahat ng laman ng partition ay isang equivalence class. So, ano ibig sabihin nun? Lahat ng laman ng partition, laman din ng equivalence class. So, lahat ng laman ng partition, laman din ng equivalence class. So, meaning, equal sila. So, therefore, yung equivalence class, yung X modulo R, yung mga equivalence class containing the equivalence classes of R ay same as the partition T. Yan. Okay? So, as a remark, again, a partition of X induce an equivalence relation on X or X whose equivalence class are precisely the sets in the partition.